Assaf Lavi. I lead the analytics team at Nexar. I am here to tell you about how we do DataOps with Snowflake and how DBT helps us do that. It's going to be about a pretty context-heavy talk, and the actual practices were pretty hard for me to illustrate. So I'm going to leave a lot of time for. I'm going to try to leave a lot of time for Q&A at the end and race through the intro parts. Okay. Nexar. What is Nexar? So we started 5 years ago with this mission of building air traffic control for the road. What does that mean? So if you think of everybody who has a stake in what's going on in the road, if it's pedestrians, drivers, city manager, like city hall, transportation agencies, ride shares, all these different parties have a very high stake in what's going on the road, that they really want to know what's going on there, but we're basically going blind, right? Because everything that's going on the road it's in the physical world, and the physical world is messy and hard to map. So Nexar took it upon itself to that mission of building this digital twin of the road, so we can provide observability to what's going on for everybody that's involved. We're currently 90 to 100 employees. We've raised a Series C recently, and things are going pretty well. I'm not going to go over all the numbers. Basic premises that users drive with our dashcam and app combo. So you buy the dashcam, you install it in your vehicle, and you install our app on your phone. And when you pair the dashcam with your phone, basically your experience of having a dashcam is completely seamless. You walk into your car, you start driving. And the camera starts recording and streams the video and additional data to the phone. Once you stop, you walk out of your car. Your phone has all the data, and if you connect to Wi-Fi, then it's uploaded to a cloud. If anything happens during your time on the road, if you God forbid, got into a collision, or even had a hard brake or harsh acceleration, any kind of unusual event can be auto-detected by the app, and a clip can be saved for that 20 seconds before and 20 seconds after that event. That's called an incident, and that entire experience is seamless. So the phone is you don't need to look at your phone, to touch your phone in order to have that experience. The value you get as a driver is pretty obvious. You have a record of what's going on and what's happening to you on the road. So you have kind of peace of mind that whatever happens, it's not just your word against another person's. So what is the business here? So we process the data that's collected over those drives and uploaded. We run them through an AI pipeline, and we assemble this digital twin of the road. We kind of identify the semantic layer of the road. So where are there construction zones? Where are there stop signs? Where did that image, where was that captured? All sorts of things that you want to know about what's going on in the road. So and those insights, once anonymized, and we really don't care about the individual person that's recorded the data, or any person is captured in the visual data. We make a very conscious effort of removing that information from the data we process on the back end. But we are interested in what's going on in the public sphere. So if there's safety alerts to reflect back to our drivers, then we do that. If you drive with some kind of forward collision warning system or a lane deviation warning, then if you extend the time range that covers, then you get what Nexar can give you. It's not just what your sensors can pick up on, it's also what the network can pick up on. We can enhance your navigation experience and give you a sneak preview of what's going on the road when you go out to drive. So that's the driver that we reflect back to our drivers, and we also have partnerships and business to business activity with private companies like mapping companies, ride shares, auto OEMs, that kind of thing, and also with governments. Whoever's managing the road, they have a very high interest in what's going on. So they want to know where there are construction zones, where there are potholes, where there are, what's the road inventory. If anybody drew a graffiti on a stop sign or anything like that, that they have a very keen interest on with that. And lastly, in the event of collision, we can also integrate with insurance companies and let them know if you agree to that. They can get a notification about your collision, start handling a claim really early, resolve any discrepancies in reporting by using the visual data that's definitive, and also provide you with a collision report after the fact if you want to make if you need evidence about what happened to you during that collision. Then we provide everything you need. This is the consumer part of the product. We have multiple dash cams that we sell. You can also buy our dash cams at Walmart and Costco and Amazon, of course. You install the app, you pair it with your dash cam, and you basically you're good to go. You have your clips, and you can already already be more at peace when you know if anything happens during a collision, you're covered. When that data gets ingested into our system, there's a multitude of things that we can produce from it, but at the end, I want you to focus on these APIs that we can produce, that we can actually expose, of where there are road items, where there are where there are road items, where there are construction zones, and also these incident APIs for insurance providers. So this is an entire backend that generates data that we want to look into. If you look at it from an analytics kind of perspective, you want to be able to analyze what's the result of all this activity from the users. So the data platform collects those video and GPS data, and derives insights from those data. The data products that we have, one of the leading data product that we sell is called CityStream, and it has multiple aspects. One is road inventory for if you're a city or a state and you want to know what's going on with everything you own that's on the road. Then we can detect that for you using the drivers in that city, and reflect back to you a live map of what's going on with your road inventory. Same goes for road work. That's something that started with a partnership we had with Nevada, with Southern Nevada, and we're able to accurately assemble these images of road work areas and reflect that back to the city that needs to enforce these licenses to block roads and so on. And lastly, our newest product called Virtual Camera, which is basically if you want to be able to subscribe to frames from specific locations, if you want to monitor foot traffic around a specific area, if you want to see whether people are driving, how much are people driving in your city if you're apropos COVID. So Virtual Camera is a very versatile product. It's still in its infancy, but but we see a lot of potential there. So I'm going to skip all this and get to what we do with analytics. So our mission at our team, it's a small team, to improve the quality, flexibility, and accessibility of the core business analytics. What does that mean? That means that we do analytics that many of you will recognize, like product, like camera activation rates from different distribution channels. We want to track product retention, user behavior with our app. We want to see which features work and which fall flat. That's kind of run-of-the-mill analytics, and but we had major problems with those requirements before. I'll get into that in a second. The second goal here is to develop these new analytical capabilities, which are not run-of-the-mill, which are unique to Nexar's architecture and business. So we'll start with the dumpster fire that is our legacy Postgres server. So we had this, we still have this single instance that's running Postgres on EC2, and it served well when Nexar started, because it's like you get going really quickly. You don't need to worry about like too much complexity. It's just one server. You insert, you query, but that didn't scale. It didn't scale. And I mean scale here in the technical sense, where with one server with one storage volume, you get resource contention pretty early when your organization and your data starts to grow. We have suboptimal performance with Postgres because it's not natively in an analytical data store. It's more transactional. So there's a lot of optimization that can be gained with Postgres, and it really struggled with large data sets. The big pain point for me as the head of analytics is having to babysit this instance so much, because it's a self-managed kind of instance. Then we need to worry about all the different auxiliary kind of concerns, like monitoring, backup, upgrades, that sort of thing. Sometimes we run out of disk, so we need to kind of either prune our data or increase the storage volume. In addition to that, we need to do a data administration on that. So any kind of operation on a table, a view, an index, you have to be a DBA basically, and that's not what I'm here to do. And we had many problems with loading diverse data into Postgres. You can use a third-party service, but it really doesn't work if you want to load large amounts of data. Didn't work for us, at least. The second pain point that's much more relevant to DBT here is data breadlines. If you imagine like this small startup that starts growing, but the data processes aren't formalized. So what happens is all this domain knowledge gets siloed in some SQL queries and in a few people's minds, and that's basically it. We're lucky if they saved some SQL scripts with that knowledge of how to define one thing or another. Additionally, if you do derive, if you define derived views or tables in your database, then you define them usually manually as a create table or create view. And those are rarely maintained and governed. So if anything changes upstream, you're not guaranteed that those relations would work, and it's a pain to maintain them. One thing that really irked me, especially when I first joined the company, is that there's no way to know the inventory of what's there. in the database. There is no catalog or kind of documentation that tells you this table defines this is tracking this entity, and it has these constraints. And as a result, you have when many people are querying this database, they're usually querying the raw data as it's coming in, and they're transforming it each to their own way. So what you get is inconsistent data quality. Some people get, and you get discrepancies and you get arguments over which is the correct definition, which is the correct metric. The result of that is that usually, if you're at least a partially functional organization, someone puts their foot down and decides that, okay, this is what's correct, and they become this pope that blesses the data, and every kind of query becomes this another work item for this person, and people are physically waiting in line to get their blessing on some queries, to know that the data they're extracting is correct. And that really doesn't scale with your organization. That doesn't matter if you have any kind of cloud data warehouse or even or a small database. You need a process to manage that organizational hurdle. So that's where DBT comes along. If I'm missing a slide here, so like obviously, what's all these problems with Postgres are resolved with were resolved for us when we migrated to Snowflake. So we have a much better experience, and we have our time back, so we can focus on the other things. And DBT really comes to the rescue for that other problem of data breadlines. So DBT is a tool that that you can use to transform your data using just simple select statements. What you do is you run pip install DBT, and in your project there you have a directory with all the different models you define, and every model is defined as a simple SQL file that's dependent on other models. So you define some source models that you actually load into your data warehouse. Those are where that graph starts. And once you have those source models, you can define derived models on top of those to basically assemble this graph of computation. So the result is that it makes the aim here is to like bring all these best practices from software engineering. If you're an engineer, you're familiar with those, to bring those into the analytics space. So version controlling and reproducing, being able to reproduce our data, being able to break up these massive queries that we used to see for a specific purpose, breaking those up into modules that you can reuse and basically become this common language that you have across the organization. You're able to test that the data you have and that the data you produce is correct. You can implement a CI or CD workflow where you actually you work on branches and you merge those, and once those are merged, they're part of the production environment. And of course, you have documentation. You can define for every kind of model that in DBT, you can define like the description and the description for every column in that model. If you're familiar with a tool like Make or Terraform, they're basically all they all have a similar premise. You have all these resources. You want to be able to recreate them and understand, and the tool helps you codify the dependencies between those resources. When you're building a software project with Make, your dependencies are libraries and binaries. But if you're building a data schema with DBT, your resources are tables, views, and so on. So you just run pip install DBT, and in your project, you can run DBT run. You can select a target if you want to run against the production workflow, the production schema, the staging schema. So you can run this on your workstation just like any command line application. You can also run, you can also use Fishtown's DBT cloud offering, or any kind of orchestration layer that you choose. So if you want to run this programmatically as part of your release, your CI/CD, then you can use whatever you like. As long as you can run that DBT run command, you're good to go. So here's just an example, just to give you a taste of how working with DBT looks like. So this is from the DBT documentation page. You just create this file called for this model called orders.sql. You define the select statement for how orders are derived from base orders and base payments. And you can see I highlighted here this Jinja kind of syntax, this double braces, and this is kind of the symbolic part of DBT, where DBT provides you with a way of symbolically addressing other objects in your project. So this assumes somewhere in the DBT project there's a file called baseorders.sql and basepayments.sql. And once DBT is invoked, it reads the entire project, assembles a graph like this, and for this file, it infers that this model called orders is dependent on model called base orders and base payments. And if you extend that kind of logic for an entire project, for an entire company, you can get this very, very elaborate graph, but every part of it is very coherent. So every model in this graph, it's completely clear to DBT how to build that from the source models, from the absolutely raw data. So what that gives you is completely reproducible analytics, a transformation layer that's completely reproducible. So if you were to gain access to Nexar's Snowflake instance, I doubt you would, but if you do, you might even delete the entire analytics database. But I would be able to to reconstruct it from zero in under an hour, just because there's a lot of data there. So this is the architecture. Just the key points here is that we transition from ETL to ELT. So what does that mean? If you're not familiar with these acronyms, so ETL is extract, transform, load. This is what this is what we analytics people used to do, and some companies still do, and there's merit in that on a case-by-case basis. But what fits better for us is ELT, because you extract and load the data as is, as just the first part. You just load data in its rawest form. You don't do any transformation on the data. And the reason you do that is once you have a cloud data warehouse, then first, storage is not such a contentious resource. So you can load the data as is, even if there's redundancy in it. And the other part is that the cloud data warehouse is powerful. So you can process this raw data into something that's more refined and usable in the data warehouse. And what you gain from that is first that all your transformations are expressed as SQL, which is very accessible to non-engineers. Compare that to if you wanted to, if you codified all your transformations in Python scripts, for instance, you'd have to know Python to understand those transformations. This kind of democratizes the transformation layer so that analysts can also take part in it. And analysts should take part in it because they're close to the business, to the business ideas and the business requirements of the organization. ELT is really smart in terms of how the organization works. And it's also smart for business continuity and disaster recovery because, as I said, you can reconstruct everything from raw data. As long as the raw data is protected, you're good to go. Secondly, any kind of data model that's not raw is managed in DBT currently at Nexar. So we don't create tables or views like manually from the console, from a workbook. Any kind of data model that's going into production is created in a DBT project and undergoes testing, pull request, code review, and so on. So we do, how are we on time, Ryan? Almost out of time, I see.
We're cutting into the Q&A, but I'm pretty sure people would like to continue hearing.
Okay, I'll start. I'm sorry, I said race, so this is race for me. Okay, so everything is done more. I'll just summarize all of this. We're building data now in a much more similar and much more reliable way, like we do with regular software. So just to recap, like our task here, the main challenge we had here was with CityStream. This product requires data at varying densities. So to understand road inventory, you need monthly or weekly data. And for work zones, you need daily data. You want your data to be fresh up to the day so you can update your work zone models accordingly. So the challenge here was to, like, the question, what fraction of Las Vegas roads did Nexar cover over the past week? So if you unpack that question, there's a lot of things that we need to do to answer it. You need you need the driving data, and what you want in the end is we covered X% of freeways, Y% of primary roads, and so on. Gonna skip map matching, hoping that you're familiar with this, but like I'll be happy to cover this in the Q&A, but I'll skip ahead. What we really loved about working with Snowflake, so Snowpipe is amazing. Like just having the data being dumped into the S3 bucket, configuring a few SQL resources gives us like continuously loading of semi-structured data into Snowflake. Warehouses are a brilliant idea. So we can balance power, we can observe, we can divide the compute resources between different requirements, and zero copy clones. The fact that we can actually clone our production environment, our production data, and actually and run a branch of transformations over that data, actually test the new transformations over real data is a game changer. So was being able to read ORC, Parquet, JSON formats, and being able to flatten nested data structures is great. My favorite feature is the qualify. I'm not sure if you're familiar with it. If you're not, please check it out. If you use window functions and you have this assign a row number to something, and in a different CTE you select for the row number that's 1 or something like that. You assign a new column and then you select on that column. Qualify just makes that much more elegant and compact. DBT, just the last slide here. So the main just the great benefit here is being able to codify the domain expertise. So lore is no more in Nexar in terms of how analytics are generated. Incremental materialization. So if you have a big table and you want to and that's constantly updated, and you want to update the derived table that's also pretty large. So you can either, without incremental materialization, you can either rebuild the table every time, or you do something like streaming or partition the data by date. Incremental materialization just gives you the convenience of having a single table that can be basically like a materialized view that you implement yourself. So we can manage with our own materialized views as incrementally materialized tables. I love the model selection, the plus syntax for DBT. If you want to build like a subset of models according to the dependency graph, you can. If you want to build everything that you want to build orders from scratch, so you want to build all its upstream dependencies from scratch as well. So you just hit DBT run plus orders, DBT run models plus orders, and you're already there.